So this long list of 1,500, I'm going through it, and each time within that loop, I'm checking if city like San Francisco is not in my list cities, then I will add it to that list. Okay? And I kind of want you to think about how much effort would it take me to figure out if San Francisco is not in my list of cities. Okay? So if I had a list called cities, okay, let's say San Francisco's here, and then you have a bunch of other cities here. Okay, 1, 2, 3, 4, 5, 6. Let's just say, okay, so there's this list of cities is 6. Okay, when I want to check if San Francisco is or is not in that list, how many times do I have to walk through this? Okay. 1, 2, 3, 4, 5, 6. Okay. And so what if SF is not in that list? How many times do I have to walk through to find out if it's in the list or not? 1, 2, 3, 4, 5, 6. Okay. So notice that this is what we call, we have a notation called big O, okay? And you'll see this where it says it takes linear time, meaning as my list grows, the amount of effort I have to take to figure out whether a value is in that list will also grow along with it, okay, linearly, okay? So if this was a list of, it already had 500 cities, and I want to check if San Francisco is not in my cities list, I would actually have to walk through, at worst, 500 of these locations, right? So think of it sort of like you're a pizza delivery person, okay? And you are told, okay, I need to deliver a pizza to Lena, okay? But I don't have a location, I just have a list of other people. So I go, are you Lena? No. Are you Lena? No. Are you Lena? No. Are you Lena?
No.
Are you Lena? Are you Lena? Are you Lena?
Yes.
Oh yes, I found it. Okay. What if I was trying to find out if I need to deliver a pizza to Tony? Are you 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 Tony? Right? Takes a long time. Okay. So that's what you get with a list. Okay. Now what if you could do this in what's called constant time? Let's say I'm a pizza delivery service and I also can teleport. Okay. So I have an address where, let's say, Pratham, okay. I need to deliver a pizza to Pratham, okay? But the cool thing is, I have a special data structure that lets me say, okay, where is Pratham likely to be, okay? And it's like, okay, Pratham's likely to be in that seat over there, okay? Every time I search for Pratham, he's always going to be in that seat. So then I just teleport over there and be like, okay, hi Pratham, here's your pizza, okay? So that's constant time because I didn't have to go through every single one of these. Even if there's 500 of you or 5,000 of you, I just teleport directly to where I expect him to be, and that's why it takes constant time, okay? So how do you do this? You can use something called a set in Python, and its underlying data structure is called a hash table. Okay? So I think some of you have seen the hash table when we looked at the ransom note. There was that video that I was showing. Okay? So who knows what a hash table is? Who wants to describe what a hash table is? Lena.
Oh. A hash table. Well, the purpose of the hash table is that you don't have to. It resolves the issue that we were saying before.
Very good.
And it's very difficult to, like, hash table can be implemented in different ways, but essentially it's like using a formula to find your spot versus asking the code to look for each one to find that spot. So essentially it's kind of like it uses a number and say Pratham is sitting at spot 5. We always know, like, you use a formula that do some calculation that you need, like, that formula would output like 5, and you know that he sits at 5.
Good, yeah. And Pratham, how do you define what you're, yeah? hash table?
Something very similar. I think form of data structures you can use by like, it is a dictionary, I think Ray just mentioned it on Slack, but yeah, it is a dictionary, you use a key, so it's easier to like locate whatever you're looking for.
Exactly, yeah, you're both correct. Okay. So I'm gonna go over what a hash table is. A hash table is actually just an array. You can think of it as like a bunch of seats where you can put people in, okay? If this is going to be a hash table of people, these are just all chairs, empty chairs, okay? And what happens is, whenever I have a value that I wanna pass in, so let's say let me pick different people. So Erica, right? When I find the string, when I put in the string Erica, I pass it through called a hash function, okay? A hash function, what it does is it takes some value, like a string, and it will give you some integer, some number. So 9976 something, some integer, okay? And the idea is that if I pass in someone else, like I pass in Mayur, I pass it through the hash function, it will give me another number that's different. 7634328, okay? So the idea is a good hash function will probably try to give unique values for different people that you're putting into this, okay? But the important thing is that every time I put in Erica, I get this exact number. Every time I put in Mayur, I'm always gonna get this same number, okay? So that's the idea of a hash function. Okay? So now, we just wanna take that hash function and we wanna map it to something where it's a position in like all of my chairs. So I have 0, 1, 2, 3, 4, 5. Okay, so I have indices 0 through 5. So something you can do is just say mod 5, okay, mod 5. So the remainder of something after you're dividing by 5 is going to be either 0, 1, 2, 3, 4, 6, mod 6, right? So I'm modding by the number of chairs I have, and the remainder, when I do division of that hash number divided by 6, is going to be either 0, 1, 2, 3, 4, or 5. Okay. Is that part okay? So the idea is that I'm trying to figure out some way I can give a unique location, so whenever I put in Steph through the hash function, it'll always give me the same hash number, and it will always jump to this location. Steph will always be located here, okay? So there you have a hash table, okay? So you have these values, and so now Steph will always be here, Mayur will always be here, and Erica will always be here, for instance, okay? So now, every time I want to look to see is Mayur in this list of people, then I pass it to the hash function. It tells me to go look in 0, and oh, Mayur's there. Okay. Otherwise, oh, if Mayur is not here, I know that Mayur is not anywhere else in the hash table. I only need to look at one location instead of all 6 of them. Okay. Now, one little note is like, some people might ask, like, well, what happens if I have a hash function? Let's say I added all these people. So I added Victoria, I added Melody, okay? And then I added Charles. Oh, it's all full, okay. So now I'm gonna add Yamini. So Yamini is going to have some number that's going to be one of these locations. So there's already somebody there. That's called a collision, okay? So a collision is when you have 2 different values, but they actually map to the same location in my hash table. Okay, so it's not a big deal. Let's say Yamini always maps to location 2, okay, where Mayur is. So actually, I would just create what's called a linked list, and then I would just add it on here. So what happens is when I'm searching for Yamini, is Yamini in this list? I would say, okay, she must be only in this location, but there's a small list here that I just need to walk through, okay? So this list will still be smaller than walking through this entire table, okay? So now I want to get into the actual code. So cities is equal to, let me use purple. City is equal to a list, okay? And then for my latitude and longitude in whatever that was, okay? My city, I grab my city from get city, whatever that function was, okay? Now say if city not in my city list, okay? Then city list dot append my city, okay? So that's what we originally had, okay? We had a list, which means that I have to walk through all these longitude, latitudes. That was 1,500 of them, okay? And then every time inside of that, I have to walk through all of the cities in my cities list, okay? So let's just assume that in the worst case, it's probably gonna end up being about 500, okay? So that means that's the number of, that's kind of the amount of effort I have to take to figure out, to run this code, okay? Even though it's fast on the computer, if you have a lot bigger numbers, then you run into issues, okay? So now I'm replacing this with a set, okay? And a set, the underlying structure, is just a hash table, okay? You can think of a set in Python as just the same as a dictionary, where the key is the same as the value. So it's the set is the same thing as a dictionary, but the key is the same thing as a value. Okay, all right. So now, instead of doing append, a set does an add, okay? So what's happening here is, when I say if city not in C, that no longer requires me to go through all 500 cities in that cities list. I only need to go to one location, and then if there's a couple collisions, then maybe just walk through a couple of them. But for the most part, we can assume that it's gonna take constant time. So we reduced the amount of effort we take for each loop from 500 down to 1, okay? Now one more optimization I wanna make a note of is pretend, so what's happening here is I'm first checking if, for example, San Francisco is not in the list, in my set, then I'm adding San Francisco. So going back to the pizza delivery analogy, this is like saying I teleported to Ken's house. I checked if he, if city not, I checked if he already has a pizza or not, okay? And I found out, oh, he doesn't have a pizza. So I teleport back to the pizza store, grab my pizza, right? And then I teleport back to Ken's house, and then I deliver the pizza. What if, while I'm checking to see if Ken is there, and if the pizza's there, I also bring the pizza with me, right? So if he doesn't have the pizza, then I just directly give him the pizza. And if he already has a pizza, I magically replace his pizza with the pizza that I was delivering, okay? Because it's the same identical pizza. So that is if I just do this. And I also need to shift this a little bit to the left, but you get the idea, right? So why do I need to check? So that's the cool thing about the set, and also with dictionaries. I don't have to check anymore because I know if it's not there, I want to add it. If it's already there, I'm just going to override it in the same exact location in the hash table. Okay. So this is what I have here. So for latitude, longitude, and blah, 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 okay. Getting the city, okay. Oh, I'll talk about this later. And here, I'm just saying my city set dot add, okay. Notice how I no longer need that if statement, okay. Before I said if city not in cities, I don't actually need to do that, okay. Also, just a shout out to Dolly and Heidi. They also searched for the country code as well. So you can search by city plus the country, because there are many cities in the world that have the same name, but in different countries, okay? For example, there's a San Jose in Costa Rica, so I want to go to San Jose, but the one in Costa Rica, okay? So.
There's a Baghdad in Arizona, but there's also a Baghdad,
Yes, I want to go to Arizona. Okay. All right. So another thing I want to note is, I think some people were talking about getting these random numbers.